All right, for the last section of chapter 2, we are going to look at absolute value functions. And these functions are going to contain an absolute value expression. Remember, that's the two straight lines around something. An absolute value means how far from 0 is that. So looking at functions and graphs, the graph of the parent absolute value function is going to be f of x equals the absolute value of x. So this right here, that's your very basic function. It has a V shape. The domain of this function is all real numbers, so we can have any x value. Those all work. But the range, the y values, are only non-negative. So you're going to start at 0 and move up for the parent function. So only positive numbers on the y-axis. The vertex of this graph is at 0, 0, and it's made up of two linear pieces, and one has a slope of -1 and the other one has a slope of +1. So if you think about a V, that's what your graph will sort of look like. And on the right-hand side, that's going to have a slope of +1 because it's going up. And on the left-hand side, that's going to be a slope of -1. So that's what that means. For example 1, we are going to let g of x be the indicated transformation of f of x equals the absolute value of x. And we need to write a rule for g of x and then graph the functions. So just like when we transformed linear functions a little while ago, the same rules apply for these. Moving the graph up or down, we're simply going to add or subtract at the end. So if we're moving it up, we're going to add however many units, and if we're going down, we're going to subtract. So moving it 2 units up, we're just going to call the new one g of x, and we're going to take the parent function, absolute value of x, and moving it 2 units up is just +2. And then for a graph, we're going to graph the parent function first. So remember up above, we talked about how its vertex is at 0, 0. And on the right-hand side, we have a slope of +1. So up 1 over 1 here for a couple of dots. And then on the left-hand side, it's -1. So up 1, left 1 for a couple of dots. And that will be called f of x. And then for g of x, we're sliding that up 2. So we're just going to take those points and move them all up 2 spots. That's our g of x. All right, sliding over here to moving our graph 3 units left. Remember, this has to be done to the x value and inside of the absolute value marks. And right or left is actually going to be opposite of what you think. So if you're going to go left, we have to add. And if we're going to go right, we have to subtract. So up or down is outside of the absolute value. Right or left is inside of the absolute value. So for this one, 3 units left, we're going to have g of x equals the absolute value of x, and 3 units left would actually be +3 inside of the absolute value marks. And then to graph this one, we are going to start off again with the parent function. So that same f of x function here. And then to slide it 3 units left, we just slide all the points over 3 spots. So our graphs aren't changing size, they're just changing the position that they're in on our graph. Now we're going to talk about the vertex here. The graph g of x equals the absolute value of x minus h plus k is the image of f of x equals the absolute value of x after a horizontal shift of 8, so, or h, sorry, horizontal is h, and the vertical is k. So we just talked about those. We just did 2 examples with those. H is going to move it left or right, and K is going to move it up or down. Okay, and then our new thing that we need to really pay attention to here, our vertex is actually at this H, K ordered pair. So you can take those out of the new equation or function and write the vertex. So for example 2, we have to translate f of x equals the absolute value of x so that the vertex is at -5, 3, and then graph it. So remember the k is what moved it up or down, and that is actually going to be the y value in our ordered pair. So if we have h, k, k is up or down, and it looks like this one is going to be moved 3. So that's a +3, so we can put +3 at the end. Actually, if I write it like this, if I copy this down, we can fill in what we know. So we know this is +3, and then we also know that h is -5. So if I plug in a -5 in for h, I'm going to have -5, which is going to turn into a +5. So there is my new function for g of x just by using that vertex. And then they want us to graph this. I went ahead and graphed our parent function f of x here, just like I have on all of the others. And then for this one, we're going to translate it up 3, and then that +5 actually means left 5. So we are going to have to count up 3 and left 5. So I'm going to start with the vertex. 1, 2, 3, 2, 3, 4, 5 would be right over here. And then from that spot, we can actually go up 1 and over 1 to get our new points in both directions. So there is our g of x. So the 5 actually told us that we're going to go left 5, and the 3 told us we were going to go up 3. But notice that 5, when we actually plugged it into the function, turned into a +5. So make sure if you're given the function, that if it says +5 in there with the x, then that has to go left. If you're given -5 in the vertex that hasn't been plugged into the function yet, that negative sign does mean left there. So kind of confusing. You have to keep those two separate. So in the function already, if it's a plus, it moves left. But if it's in the vertex form and it's a negative, then it moves left there. So be careful. Take a couple of minutes to make sure you're doing the right thing. All right, and then 2 more examples here. Perform each transformation and then graph. So we have to reflect this graph, f of x equals the absolute value of x plus 2 plus 1 across the x-axis. So if you remember, to reflect across the x-axis, we actually take that whole function and make it opposite. So we're going to have g of x equals negative absolute value of x plus 2, and then that plus 1 is going to be -1. And we can take and figure out what the vertex of this is just by knowing hk. Remember, h is on the inside with that x, so it's +2, so h is actually -2. And then k is on the outside. This one is at +1, so add 1. So the original is -2 plus 1. So that's our f of x. And then our g of x, we are going to have still that -2 but we have -1 on the outside. Oops. And that's for g of x. Right, so starting off with the vertex of f of x, we're going to have -2, +1 is the vertex. And we know that on the right-hand side, we have a slope of 1, so up 1 and over 1. And then -1 on the left-hand side, so up 1 and back 1 to the left. So this will be our f of x function. And then we can think about a reflection over the x-axis. We're just going to flip it. So that vertex is 1 up, so our new one would be 1 down. This other point is 2 up from -1, so we're going to go 2 down from -1. And the same thing with the point on the other side, on the left-hand side, it's 2 up, so we're going to go 2 down over here. And that would give us g of x. And then we can kind of look, that ordered pair is -2, -1. And if you look right here, that's what the ordered pair from our new function that we wrote was for our vertex. So we know we got that right. Our next one, we're going to have to stretch the graph vertically. And if you remember the rule for that, we just take the factor and multiply it by the entire function that we are given. So we are going to have g of x equals the absolute value of x minus 2. That is our entire function, and we're going to times that by 3, which is our factor. So that's going to simplify to 3 times the absolute value of x, and then 3 times -2. So remember, we're distributing here. 3 times -2 is -6. So that would be our new g of x. And to graph that, I'm going to use Desmos graphing calculator, just for the simple fact that if we don't use a graphing calculator or this online one, we're going to have to plug in values of x and do all of the math to find some ordered pairs to graph. So this is a little bit quicker. So I graphed the two functions here, and you can see the blue one has been squished a little bit more and then slid down. So that's what that graph would look like. And then for our last question, we are going to have to compress this by a factor of 0.5. And to compress, we only have to multiply the x by 1 over our factor. So our g of x is going to be the absolute value of 1 over 0.5x minus 1 and then minus 3. Some time here, 1 over 0.5 is like 1 divided by 1/2. So that's keep, change, flip. So I did that over here and got 2 for my answer. So g of x is really absolute value of 2x minus 1 minus 3. And then we'll graph those on the graphing calculator as well. So you can see the blue one has definitely been compressed. It's been slid over a little bit. And that's what your graph would look like. I do want to point out, when you're using absolute value, if you're going to use this Desmos calculator, you have to go to the numbers and then hit this arrow here to use this straight up and down line that's right here. So I encourage you to definitely use the graphing calculator. It saves a little bit of time and makes your life a little bit easier.